Now let us go through Poisson's and Laplace equation. So next topic we need to study about Poisson's and Laplace equation here. So Poisson's and Laplace equations, once again I'll tell you, it plays a very important role in all the communication system, and I've given assignment what is the applications of each of the theorem. You have written the applications by listing 5 to 6. So all of you will be knowing the applications of each of the theorem. So it is in general, if you want to tell, for all the communication system, all these losses are used, and for the physics or explanation of any phenomena, if you take, we are using this Poisson's and Laplace equation. How do we arrive at this? So in order to derive Poisson's and Laplace equation, we consider the Maxwell's first equation, or Gauss law in point form or differential form. So what is Maxwell's first equation? Del dot D is equal to rho V. That is first equation. Then we have the relation between field and flux density is what? D is equal to epsilon into E. The value of D is equal to epsilon E is substituted in equation 1. So what does equation 1 LHS becomes? It is del dot epsilon E is equal to rho V. Then epsilon is constant, you can remove outside and it will become del dot E. That is represented in equation 2. Then we have derived in the last class field and potentials is related by what? E is equal to minus del V. So the value of E in equation 2 can be replaced by minus del V. So what does that equation 2 results? Epsilon is outside, del dot, and vector E is replaced by minus del V. So then if you simplify that, minus you can remove outside, that is minus epsilon. In the bracket we have del dot del V, that is equal to rho V. And you should know in the dot product, del dot del is equal to del square. So it becomes minus epsilon del square V is equal to rho V. So finally del square V is equal to minus rho V by epsilon. So this is del square V is equal to minus rho V by epsilon is called the Poisson's equation in the electric field. Then using this Poisson equation, we can derive the Laplace equation, which plays a very important role. If you assume in a particular region, if rho V is 0, that is volume charge density is 0, then equation 4 becomes del square V is equal to 0. So this del square V is equal to 0 is represented in equation 5. This equation is called as Laplace equation in electrostatics. So we have derived now Poisson's equation as well as Laplace equation here. So what is that? Poisson's equation we have from Maxwell's first equation, del dot D is equal to rho V, and D is nothing but epsilon into E. Replace this value in equation 1, so it becomes del dot epsilon E. Epsilon is a constant term, you remove outside the bracket, so it becomes epsilon of del dot E is equal to rho V. And we have arrived at the relation between electric field intensity and potential, that is E is equal to minus del V. So in equation 2, you can replace E by minus del V. So minus you can remove outside. So if you simplify, you get what? Minus epsilon del dot del V is equal to rho V. And according to the dot product, del dot del is del square. So it becomes minus epsilon del square V is equal to rho V. So finally del square V will be equal to minus rho V by epsilon. So this is called Poisson's equation in electrostatics. And from this equation we can derive the Laplace equation, that is in a region if volume charge density rho V is 0, so equation 4 will result in del square V is equal to 0. So this is called what? Laplace equation in electrostatics. So once you derive Laplace equation, we need to express this Laplace. All of you know in Cartesian, cylindrical and spherical it should be expressed. So what all we have expressed in three different forms? First we have expressed del. Del operator you should know in Cartesian, cylindrical, spherical. Similarly del dot D, that is divergence. Then next is del V, how to represent in Cartesian, cylindrical, spherical. And finally we are representing del square V in all the three coordinate system. All these four terms you should know for each of the coordinate system clearly. So in Cartesian coordinate system, the point is represented as x, y, z. So how do we write? Del square V is equal to, it is dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square is equal to 0. So this is in Cartesian form. Same thing if you consider in cylindrical form, the Laplace equation is 1 by rho, rho by dou rho of rho, dou v by dou rho, plus 1 by rho square, dou square v by dou phi square, plus dou square v by dou z square is equal to 0. And in spherical form, del square v is given by what? 1 by r square, dou by dou r of r square into dou v by dou r, plus 1 by r square sine theta dou by dou theta of sine theta into dou v by dou theta, plus 1 by r square sine square theta times dou square v by dou phi square, that is equal to 0. So these are the three Laplace equations. First one is in Cartesian form, second one is cylindrical form, and third one is in the spherical form. So all of you should remember these equations. Now, so we are calculating, first thing what we are doing here is, if they give some potential, whether that potential satisfies Laplace equation, we are verifying it for a given medium. So what is the first type of solutions or problems we are finding here? If a potential is given, is this potential satisfies Laplace equation, you need to verify. So here also I have given three sets of potential. First one is in Cartesian, second one is in cylindrical, third one is spherical. So each of the potentials, you have to calculate the corresponding Laplace value and prove whether its value is 0 or what. So first one, if you consider, the V is given as 2x square minus 3y square plus z square. So since it is x, y, z, you should understand it is in Cartesian coordinate. So write the corresponding Laplace equation in Cartesian form. So how do you write Laplace in Cartesian? Del square V will be what? Dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square. That is represented in equation 1. So you consider whatever the potential is given V, then you need to differentiate this potential V, first one with respect to x. So dou V by dou x, what is 2x square differentiation? It is 4x, and rest all the differentiation will become 0. Then again if you differentiate with respect to x, 4x differentiation is 4. So dou square V by dou x square will be equal to 4. Similarly, you need to do for y. So for the given potential V, dou V by dou y becomes what? It is with respect to y, x and z differentiation is 0 and y square differentiation is 2y. So there is a coefficient minus 3, so it becomes minus 6y. Again, if you differentiate minus 6y with respect to y, what does it becomes? It becomes minus 6. So that is given in equation 3. And the last derivative you need to find is with respect to z. So potential V is having z square here. So if you differentiate with respect to z, what happens? X and y derivatives will be 0. Z square differentiation is 2z. Again, if you differentiate, 2z differentiation is 2. So finally, calculated what all? From dou square V by dou x square plus dou square V by dou y square value and dou square V by dou z square. All these three are represented in equation 2, 3 and 4. We need to substitute all these three values in equation 1 So what happens? Equation 1 becomes what? That is 4 minus 6 plus 2. If you add all the terms, it will be equal to 0. So what does this indicate? The given potential satisfies Laplace equation. So we are proving del square V is equal to 0. So this is the first problem in Cartesian. So similar way you can solve in cylindrical form. So what knowledge you should have here? You should have basic differentiation knowledge. Then you need to know the formula. Then simplification should be done clearly. Next, let us do second one is given what? V is equal to A rho power 4 plus B rho power minus 4 into sine 4 phi. So write this in cylindrical form. Laplace equation in cylindrical form is given in equation 1. So according to equation 1, we need to differentiate. So consider V whatever is given. Now I told you in the previous classes while calculating divergence and all, always the derivative should be carried from the inner term, not from the outside. What does that mean? In equation 1 in the RHS, if you consider the first part, it is inner term starts from dou v by dou rho, not from 1 by rho. You should not start. So first you need to calculate what? Dou v by dou rho. What is rho differentiation inside the square bracket? You have rho power 4. So rho power 4 differentiation is 4 rho cube, and rho power minus 4 will become minus 4b rho power minus 5. And sine 4 phi is constant, you keep as it is. Next, according to equation 1, this should be multiplied by what? Rho on both the sides. So if you multiply rho on both the sides, rho dou v by dou rho becomes what? You have to divide RHS by rho. So what does, multiply by rho. So the bracket value becomes what? 4a rho power 4 minus 4b rho power minus 4, because minus 5 plus 1 will be equal to minus 4. Then you need to differentiate once again with respect to rho. So what is the bracket differentiation here? Rho power 4 is 4 rho cube. So already 4 is there, so it becomes 16. So the bracket value should follow this when I'm teaching. If you follow the screen, then only you can understand. So differentiation I'm telling step by step how to do. So rho power 4 inside the bracket differentiation is 4 rho cube. Already 4a is there, so it becomes 16a rho cube plus second term is rho power minus 4. So its derivative is minus 4 rho power minus 5. So if you multiply, you get plus 16b rho power minus 5, and sine 4 phi is constant. Then after finding this derivative, you need to multiply by 1 by rho or divide by rho on both the sides. If you divide by rho, RHS becomes what? You have rho cube. So rho cube divided by rho is rho square. Rho power minus 5 divided by rho will become rho power minus 6. So in equation 1, whatever the derivative is there in the RHS of the first term is calculated as shown in equation 2. And what is the second term we need to find? In equation 1, we have dou square v by dou phi square multiplied by 1 by rho square. So you can differentiate first what? The potential with respect to phi. All the rho term is constant here, you keep as it is. Sine 4 phi differentiation is what? Cos 4 phi into 4. Then again you need to differentiate it. Cos 4 phi differentiation is what? Minus sine 4 phi into 4. And if you simplify, you'll get some value. Then again you need to multiply by 1 by rho square on both sides. So if you multiply, you'll get that equation 3. Finally, the last one in equation 1 in the RHS, we need to calculate what? Dou square V by dou Z square. So differentiate the given potential with respect to Z. If you observe, the given potential does not have any term with respect to Z, so its derivative, either first derivative or second derivative, will be equal to 0. So after calculating all these three derivatives that is represented in RHS of equation 1, you need to substitute all these values back in equation 1. That is 2, 3 and 4 values are substituted in 1. And then if you simplify, what happens here? You have similar terms with plus and minus, so it will get cancelled. So finally what you get, you'll get its value to be 0. So what does this indicate? The second, that is cylindrical coordinate system also, the Laplace equation is satisfied. I hope all of you, and all these are standard problems, so you need to practice this. And last one is the spherical form. So spherical form Laplace equation, sorry, potential V is given in spherical because it is in the form of A ln tan square theta by 2 plus B. Theta is related to which one? Spherical, so it is in spherical form. So write the Laplace equation for the solution in spherical form, which is given in equation 1. Then you consider the given potential V, that is A ln tan square theta by 2 plus B. According to equation 1, what you need to do? You need to calculate the first term in the RHS. What is that? I told you should differentiate from the inner side, not from the outside. So calculate dou V by dou R. In the given potential, there is no R term. So whatever you do with respect to R, everything will be equal to 0 here. So dou V by dou R is 0. If you multiply by R square, that is also 0. Again, differentiation will be 0. Again, multiplying by 1 by R square will result in 0. Since dou V by dou R is 0, whatever multiplication, differentiation, everything results in 0. That is represented in equation 2. And next you have to calculate what? Dou V by dou theta. So you have a theta term in this. So in the given potential, if you observe, you have theta, so you'll get some derivative. Now, how do we differentiate this? Listen here. Dou V by dou theta. A is constant, you remove outside. And what is ln tan square theta by 2 derivative? So you have so many terms are there, so you need to apply chain rule for this. What is the chain rule? Ln differentiation or log differentiation is 1 by some term, that is log x is 1 by x. So ln tan square theta by 2 will be 1 by tan square theta by 2, that is first. And what is tan square theta by 2 differentiation? It is 2 tan theta by 2 into, so it is 2 tan theta by 2, and then it is for power. So sorry. So ln tan square theta by 2 derivative is ln differentiation is 1 by tan square theta by 2. And then you have x square like that. So x square differentiation is 2x. That is tan square theta by 2 is 2 tan theta by 2. Then you need to differentiate tan theta by 2. What is tan differentiation? It is secant square theta by 2. And then theta by 2 differentiation is half. So like this, we need to apply chain rule because it has multiple terms inside. First one, ln differentiation is 1 by tan square theta by 2, and x square differentiation is 2x, that is 2 tan theta by 2. Tan differentiation is secant square theta by 2, and theta 2 differentiation is half. And if you simplify here, you'll get secant square by tan theta by 2, and you know secant is reciprocal of what? Cos square. So secant square can be written as 1 by cos square, and tan is what? Sine by cos. If you shift to numerator, it becomes cos by sine. If you simplify, what you get? A divided by 1 sine theta by 2 into cos theta by 2. And all of you should know this half angle formula. You can divide and multiply by 2 so that this 2 sine theta by 2 cos theta by 2 can be represented as sine theta. So this is using half angle formulas you should know. Then after converting this dou V by dou theta to A2 by sine theta, then you need to multiply by sine theta on both sides according to equation 1. So sine will get cancelled, you get 2A. Then if you differentiate 2A with respect to theta, it is 0. Then again if you multiply by 1 by r square sine theta, that is also 0. So the second derivative finally results in 0. And the last one you should do with respect to phi. in the given potential, if you observe, there is no phi terms. So whatever you do with respect to phi, everything will be 0. So you get dou square V by dou phi square is 0. So put all these values where after finding all the differentiation of the Laplace equation terms, substitute all these three in equation 1. So finally all the terms is 0. So the sum also results in 0. So this indicates the given potential V in cylindrical form also satisfies Laplace equation. Sorry, in spherical form also satisfies Laplace equation. So I hope all of you understood what is the simple problem we are doing here. They have given the potentials in all the three coordinate system. Just you have to write the Laplace equation in Cartesian, cylindrical and spherical, and do the carry out the derivatives and see the sum of all the derivatives is equal to 0. Since all are equal to 0 in this particular cases, it satisfies Laplace equation in all the three coordinate systems. Next we'll solve some few other two types of problems are there. What is that? So we need to find the constant A and B that is present in the potential V. So in order to find this A and B, they have given some values. That is, the magnitude of the electric field intensity is 500 volts per meter, and the potential that exhibits is 100 at the point 122.5 degrees and 2. So they've given a statement here such that you need to calculate the constants A and B in the given potential V. In order to calculate these two constants, they have given magnitude of electric field intensities to be 500 volts per meter and the potential is 100 volts. Both of this is defined at the point 122.5 degrees and 2. So it is very simple. Whatever previous method you followed, that equation you have to apply here. See, listen here. So we need two parameters to be found or two constants A and B. So in order to calculate two unknowns, you should have at least two simultaneous equations to solve. So for the given potential and electric field intensity, you need to derive two equations in terms of A and B. So how do you calculate here? So they have given the potential V, first thing. So in this potential V, you substitute the point. So what is the point given? 122.5 degrees and 2. So you put that point, that is rho pi z, in the given potential, and then they've given V to be 100. So what you need to substitute here in the given potential, you need to put the point P value, that is 122.5 degrees comma 2, and the corresponding potential at the point is given 100. So if you substitute these two values in the given potential, what happens here? Rho is 1 and then phi is 22.5. So 4 into 22.5 is sin 90. Sin 90 is equal to 1. So you'll get an equation that is 100 is equal to A plus B. So you get A plus B, one equation for the given potential. Then they have given electric field intensity. So you know the relation between electric field intensity and potential. So what it is, E is equal to minus del V relation we know. So since it is in cylindrical form, write the equation in cylindrical. What is del V in cylindrical? All of you should know. Dou V by dou rho A rho plus 1 by rho dou V by dou phi A phi plus dou V by dou Z A Z. Then the given potential differentiate with respect to what? Rho, phi and Z. First one you differentiate with respect to rho. You have done in the previous one. Rho power 4 is what? 4 rho cube, and rho power minus 4 is minus 4 rho power minus 5. Then next you have to put the given point values. You'll get some terms, that is 4a minus 4b. Then you need to differentiate with respect to phi. So sin 4 phi differentiation is cos 4 phi into 4. Then multiply by rho on both sides. Then what happens here? You'll get cos 90. Cos 90 is always equal to 0. So the second derivative will become 0. And the last one we have dou v by dou z. In the given potential there is no z, so its differentiation will be 0. So in this del v we are calculating all the three derivatives and we are substituting back. So finally E becomes what? It's given in this page here, that is 4b minus 4a into a rho you get. So you are calculating the electric field intensity from the potential V. So you are getting E as minus 4b minus 4a into a rho. Then you need to take magnitude on both sides. So what is magnitude here? Magnitude of E is square root of that line, you cancel it, it's written wrong. So if you take magnitude on both sides, square root of 4b minus 4a the whole square. Square and square root will get cancelled, so magnitude E is equal to 4b minus 4a. And then E magnitude is given as 500. You substitute the E value, you'll get another equation in terms of A and B. So after deriving the electric field intensity expression from the potential V, now you can solve the equations. What are those equations you have to solve? That is 100 is equal to A plus B, that is equation 1. Then the sixth equation. So if you solve those two simultaneous equations, you get A to be minus 12.5 and B to be 112.5, that is 112.5. So these are the constants A and B that is obtained for the given potential V having a voltage of 100 volts and the magnitude of electric field intensity is 500 volts per meter, that is specified at a particular point. The same way I'm doing the other one in spherical coordinate system. The principle behind it is same as the previous one. Instead of cylindrical, you do it in spherical here. So what is V given here? A ln tan square theta by 2 plus B. So what you should do here, put the point, that is r theta phi. What is r theta phi specified here? R is 2, theta is 35 degree and phi is 45. You put these values in potential V and V is given to be 100. You'll get a equation first. Then what is the other equation? Electric field intensity in terms of del V, you know. So write that del V. Then you know how to differentiate. Now I told you in the previous problem, you need to calculate first what? Dou V by dou R. There is no R term, so first derivative is 0. And next is dou V by dou theta. I told you how to derive dou V by dou theta. You do again, it will be 2a by sine theta, then multiply by R, then you put the point. And last one with respect to phi there is no term, so what happens? Its differentiation is 0. So in this equation 2, whatever differentiation is there, you calculate and substitute back all these in 2. So you will get a electric field E becomes what? Minus 1.7436 A into A theta. Then you take magnitude on both sides. So magnitude is what? Magnitude of E LHS is equal to square root of minus 1.7436 the whole square. Square and square root gets cancelled, you get some value 1.7436A. And what is magnitude of E given in the problem? It is 500. You substitute E value, you'll get the A. Once you get this A, you substitute back this A in equation 1. That will give you the B value. So like this, A and B is calculated for the given potential and electric field at a particular point. So what is the relations we have to use? E is equal to minus del V. If you use, you'll get another equation in terms of A and B. And for the given potential, you'll get one equation. Solve those two simultaneous equations, you'll get the value for A and B. See, if you follow this, it is very simple. But only thing, you should have a basic knowledge and you have to practice it, the main thing. So in this class, we have studied about what? So we have studied about Poisson's and Laplace equation. How do we arrive? So what is Poisson's equation? Del square V is equal to minus rho V by epsilon we derive. And in a medium, if rho v is 0, del square v is 0, that is Laplace we derived. And how to write Laplace equation in all the three forms, that is Cartesian, cylindrical and spherical we did. And potentials in Cartesian, cylindrical and spherical, whether it satisfies Laplace equation, we have proved for all the three. Then in the last two problems, what we have discussed, if they give potential and electric field, how do we calculate the constants A and B in the given problem? So we have done in form of cylindrical as well as spherical.